Hello friends, you are watching Being Mathematician. Today I discuss about a conceptual topic, that is, when the coefficient of a quadratic equation are in GP, then what will be the nature of the roots of the equation. So the question which is related to the topic is, in a quadratic equation, the coefficient of x square, comma, coefficient of x and coefficient of x to the power 0 are in GP, then prove that one root of the equation is either omega times or omega squared times the other root of the equation. So without any further delay, let's clear the concept with solving this problem. Let us assume that the equation is ax square plus bx plus c equal to 0. So the coefficient of x square is a, and coefficient of x is b, and coefficient of x to the power 0 is c. So a, b, c are in GP. So clearly, by the concept of GP, we get b square equal to AC. Now, let alpha and beta are two roots of the equation. So obviously, alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. Now multiplied by a to the numerator and denominator, we get a square by ac, and now we know that the value of ac is b square, so we can write b square by a square equal to alpha beta. So now in this relation, squaring both sides, so we get alpha plus beta whole square equal to b square by a square, and now we can write alpha plus beta whole square is equal to alpha beta, since both of the term is equal to b square by a square. Now this is simplified as alpha square plus 2 alpha beta plus beta square is equal to alpha beta, and now alpha beta plus beta square equal to 0. Now divided by beta square, we get alpha square by beta square plus alpha by beta plus 1. Obviously beta is not equal to 0, because consider that alpha and beta are non-zero roots, since c is not equal to 0. So now apply Sridharacharya's formula for the solving this equation, that is, which is a quadratic equation of alpha by beta. We can write the equation like this, and now we write alpha by beta is equal to minus 1 plus minus root over 1 minus 4 by 2. Now the value is minus 1 plus minus root 3i by 2, where I is root over minus 1. So obviously we know that this value minus 1 plus minus root 3I by 2, this value is either omega or omega square. So we write alpha equal to beta omega or alpha equal to beta omega square. And when we multiply omega square on both sides to this result, we get alpha omega square is beta omega cube, and we know that omega cube is 1, so it will be beta. So beta is omega square time alpha, and then alpha is omega time beta. And when this result we multiply it by omega, then we get beta omega cube and it will be beta. So alpha omega is equal to beta. So we can see this, that one root of the equation, that is one root of the equation is either omega times of another root, that is beta, or omega squared times another root, that is beta. And the property is true for the beta is equal to omega squared time alpha, and beta either this and or beta is equal to omega times the alpha. So we can see the nature of the roots of the quadratic equation whose coefficients are in GP. Our next question is related to almost same topic, but here the coefficient of the quadratic equation are in AP. Then what will be the nature of the roots of the equation? So let us discuss the question first. In a quadratic equation, the coefficient of x square, comma, the coefficient of x and coefficient of x to the power 0 are in AP. Then find the range of the roots on R means real number, comma, when they are of opposite sign. So without any further delay, let's start the video and clear our concept about this topic. First of all, let us assume a quadratic equation ax square plus bx plus c equal to 0. And by the question, the coefficient of x square is a, coefficient of x is b, and coefficient of x to the power 0 is c are in AP. So therefore 2b is equal to a plus c. This is the basic property of AP. Now apply the properties of roots and coefficient of the equation. We get alpha plus beta is minus b by a, and alpha beta is c by a. Therefore we take alpha beta equal to c by a, and 1 plus alpha beta is a plus c by a. And now putting the value of a plus c, which is 2b, so we write 2b by a, and we know that b by a is minus alpha plus beta. So we simplify. This will be minus 2 alpha minus 2 beta. So all terms move to left and we get 2 alpha plus 2 beta plus alpha beta plus 1 equal to 0. And now 2 alpha plus 1 plus beta into alpha plus 2 equal to 0. So beta is equal to minus 2 alpha plus 1 whole divided by alpha plus 2, and this is the relation between the roots of the equation. So clearly alpha is not equal to minus 2 and alpha is not equal to minus 1 by 2, since alpha and beta are non-zero roots, and alpha is not equal to 2 because alpha plus 2 should not be 0. So we can say when alpha is, the value of alpha is between minus 2 and minus 1 by 2 and union of open interval minus 1 by 2 comma 0, then beta is always positive, greater than 0. And when alpha is between semi-closed interval 0 comma positive infinite, then beta is always less than 0. So this is the range of the roots when the coefficient of the equation are in AP, and here clearly alpha is positive and beta is negative, and here alpha is negative and beta is positive. So we have the solution of the problem is the range of the roots is when alpha minus 2 minus 1 by 2 union minus 1 by 2 comma 0, and then beta must be greater than 0, and when alpha belongs to 0 comma infinite plus infinite, then beta must be less than 0. So this is the range of the roots of the equation when the coefficient of the equation are in AP. So I think you understand the problem clearly, and you cleared your concept about this topic.
Get more interesting videos, subscribe this channel, Being Mathematician, and for notification press bell icon.